Hello everyone, welcome to the YouTube channel of Oiko Ipsum. This video is the second video of the video series on intermediate statistics for economics. In the first lecture of intermediate statistics, we have learned about a random experiment, sample space, sample points, an event, and how to demonstrate sample points in a Cartesian diagram, and finally we learned about the probability. Please feel free to check that video. In this lecture I will tell you about 1. The two approaches to the concept of probability, 2. 3 axioms of probability, and finally, some of the important theorems on probability. Alright, let's get started then. We can talk about two different approaches to the concept of probability. The first approach is called the classical approach. Basically, this approach is based on equally likely outcomes. As we did in the first lecture, once again, let's think on an experiment. This time, we toss a fair die. As you know, there are 6 different possible outcomes of this experiment. These are 1, 2, 3, 4, 5, and 6. In this experiment, if the die is fair, the probability of each number's appearing is the same. Because there are 6 different numbers, their probability of come up is equal at 1 divided by 6, which approximately equals at 0.16. To generalize this result, we can say that in the context of classical approach, if n represents the possible outcomes, then the probability of each outcome is equal at 1 divided by n. The second approach to the probability is the frequency approach. This approach can be better explained by the idea that if an experiment repeated a large number of times under the same conditions, the frequencies of outcomes approaches to the certain values. That is to say, for example, if we toss a die for, let's say, 10 billion times, the occurrence ratio of each number will be equal at 0.16 or 1/6. Now that you have learned about the classical approach and probability approach, we can continue with the axioms of probability. Capital P represents the probability function, while capital A is an event. The first axiom is that the probability of an event is larger than or equal at 0. This means an event either occurs or not occurs. The second axiom is that the probability of all sample space is equal at 1. This means that in the framework of second axiom, the probability of all sample space is equal at 1. Think about tossing a die only for once. We have either heads or tails in our sample space. Because each of the probabilities of outcomes occurring is equal at 0.5, if we sum them up, we end up with the result of 1. The third and final axiom says that if A1, A2, A3, and lastly an AN are mutually exclusive events in sample space S, then the probability of A1 intersection A2 intersection A3 intersection AN is equal at nothing more than the summation of the probabilities of these events. Now, in this part of the lecture, we will have a look at some important theorems on probability. Actually, there are 8 of them. 1. If A1 is a subset of A2, then the probability of A1 is less than or equal at the probability of A2. In this circumstance, the probability of A2 subtracted by A1 will be equal at the probability of A2 minus the probability of A1. 2. For every event A, the probability of A will be larger or equal at 0 and will be smaller or equal at 1. 3. The probability of an empty cluster is equal at 0. 4. If A complement is the complement of A, then the probability of A complement is equal at 1 minus the probability of A. 5. If A is equal at A1 union A2 union, this goes on until AN, while A1, A2 and continuing until AN are mutually exclusive events, then the probability of A is equal at the probability of A1 plus the probability of A2 plus this goes until the probability of AN. And if A is equal at S or the sample space, then the probability of A1 plus the probability of A2 plus all the A's until the probability of AN are equal at 1. 6. If A and B are any two events, then the probability of A union B is equal at the probability of A plus the probability of B minus the probability of A intersection B. 7. For any events A and B, the probability of A is equal at the probability of A intersection B plus the probability of A intersection the complement of B. 8. If an event A must result in the occurrence of one of the mutually exclusive events A1, A2 and all the A's until the AN, then the probability of A is equal at the probability of A intersection A1 plus the probability of A intersection A2 plus this goes until the probability of A intersection AN. Alright, this brings us to end of the lecture. The lecture note and the lecture posters for the videos will be available on the internet site of Oiko Ipsum. Don't forget to push the like and subscription button and please visit the internet site of Oiko Ipsum. I will see you in another video. Bye.